Let's try to understand the kinetic interpretation of temperature now that we have understood how the pressure works. So assume that m is the mass of one molecule of the gas. Then total mass m is equal to m into Na. Na is what? The Avogadro number. Correct? Now here C is the RMS value. That is the root mean square value, whatever I have told in the last video. Now what do we get? P is equal to 1 by 3 rho into C square. Or the same thing can also be written as what? 1 by 3 into m by v into C square. Now equate these two. That is PV is equal to 1 by 3 mc square. Make sense? But what do we know? PV is equal to RT. This is for 1 mole, correct? PV is equal to RT. So what do you get now? RT is equal to 1 by 3 mc square. So mc square is equal to what? 3RT. Now divide both the sides by half. That means you'll get half mc square is equal to 3 by 2 RT. Now this is the kinetic interpretation of temperature, because we have the temperature parameter and we also have the RMS, which is basically the kinetic energy of the particle, correct? So this represents the kinetic interpretation of the temperature. Now we know that capital M is equal to M into Na, right? Now substitute that in the formula. What do you get? Half M Na into C square is equal to 3 by 2 RT. Half MC square is equal to what? 3 by 2 into R by Na into T. Now R by N is what? That's a Boltzmann constant, right? Now you get half mc square is equal to 3 by 2 into kb into T. The same thing we can write in terms of the Boltzmann constant. So these two formulas, they represent the kinetic interpretation of the temperature. So how does actually temperature change the kinetic energy?